Hello everyone, welcome back to our session on operational research. The topic that we are going to start today is transportation model, which is commonly referred as a distribution model. So transportation model is a specific linear programming problem. So it is a specific linear programming problem in which goods or commodities are shipped. So shipping is done from the source to the destination, and obviously the constraint will be minimizing the transportation cost. And this is done considering the demand and supply constraint. If we put this all together, we get transportation model or distribution model. So generally, transportation model is represented in a matrix form in which the cell values represents the cost of transportation. Okay, and to optimize it means to minimize the cost of transportation. In some circumstances, the cell value might also represent the profit earned. So in that case, we need to maximize. But majority of time, the transportation model problem is of minimization. Next. So in each and every transportation problem, we will be given with the demand and supply. So this transportation model can be of two types. First one, it can be a balanced transportation problem, where the demand and supply will be same. So where demand equal to supply, the problem will be referred as balanced transportation problem, and where the demand and supply is not same, it will be called as a unbalanced transportation problem. So demand is not equal to supply. Such problem are referred as unbalanced transportation problem. Okay, so it becomes very much important that before solving the problem, we need to check whether it is of whether it is of balanced transportation problem or unbalanced. If it is balanced, then we can solve it by various methods. But if it is not balanced, then we need to balance the problem first, and then we need to incorporate the methods for solving the transportation model. Okay. There are certain important terms as far as transportation model is concerned. So let us discuss those terms. The first important term in transportation model is feasible solution. Okay, so feasible solution is nothing but we give or we allocate certain non-negative allocations. What exactly are allocations? We will be seeing further with the help of some numericals. Meanwhile, feasible solution is we allocate certain non-negative allocations, okay, and these allocations satisfy our row and column constraints. So what exactly are row and column constraints? That we will be seeing while solving the numerical. Second important term is basic feasible solution. So the basic feasible solution states that the number of non-negative allocations. So non-negative allocations or number of non-negative allocation should be less than or equal to m plus n minus 1, where m plus n minus 1 is m is number of rows of the matrix, n is number of columns. So if number of allocations is less than or equal to m plus n minus 1, then the solution is called as basic feasible solution. Okay, this basic feasible solution can be categorized into two types. The first one is non-degenerative basic feasible solution. Non-degenerative basic feasible solution where number of allocations is exactly equal to m plus n minus 1. First important point. And also non-degenerative basic feasible solution means we don't have any independent position allocation. Okay, so allocations are at independent position. All allocations are at independent position. Independent position means if we form a closed loop in the allocations, then it becomes dependent position. But here all the allocations should be at independent position. So obviously closed loop won't be formed. So here we can write down no closed loop formation. So the basic feasible solution is categorized into number 1, non-degenerative basic feasible solution, and number 2 we have degenerative basic feasible solution. So degenerative basic feasible solution, the number of allocations is less than m plus n minus 1. Okay, so to simplify, the number of allocations, that is non-negative allocation, should be less than or equal to m plus n minus 1, where m is number of rows, n is number of columns. If it is exactly equal to m plus n minus 1, then the basic feasible solution will be called as non-degenerative basic feasible solution. And if the number of allocations is less than m plus n minus 1, then it will be called as degenerative basic feasible solution. And number 3rd, we have optimal solution. So whatever might be the solution, if this solution gives the minimum value for transportation cost, or if it gives maximum value for profit, then such type of solution will be referred as optimal solution. So optimal solution can be feasible one, it can be basic feasible one, it can be degenerative or non-degenerative, doesn't matter. Okay, so this is all about introductory part of transportation model or distribution model. There are 5 important solutions that we need to keep in mind. The first one is basic feasible solution. The second one is basic feasible solution. The basic feasible solution can be categorized into non-degenerative and degenerative, and the next one is optimal solution. Okay, now to solve this particular matrix or to solve this particular transportation problem, there are certain methods. So first of all, we will see those methods and then we will solve the numerical by each method. Okay, so methods. Let me list down some method. The first method is northwest corner method. We will be solving each and every numerical with the help of each and every method. So at that time we will discuss it in detail. Meanwhile, let's just list down the method. So first one is northwest corner method. The second one is called as row minima method. The third one is column minima method. The fourth method is least cost method. And the final method is Vogel's approximation method. Which is also referred as VA method. Now all these 5 methods are the method which gives us initial basic feasible solution. Okay, not necessary that this particular solution that we are getting at the end of these 5 methods is optimal. Okay, so to go for optimal solution, from this basic feasible solution to optimal solution, we have 2 methods which check the optimality and it gives the optimal solution. The first method is called as modified distribution method. That is MODI method. It is also referred as UV method. And the second method which gives us the optimal solution is called as stepping stone method. Okay, so we will be discussing all these methods. So now let us start with the first method, that is northwest corner method, which will give us the initial basic feasible solution.